the first definition that we're going to define is a congruency statement, and this is what we're going to use this entire unit is a congruency statement. It's really, really important that you use your congruency statement throughout this entire chapter. A congruency statement is just simply a statement that lists the corresponding or matching parts of congruent polygons. So for our first example, we're going to list the sides that are congruent to each other given that triangle ABC is congruent to DEF. This right here is our congruency statement. And it tells us without a picture which angles and which sides are congruent to each other. So if you remember, sides are named with 2 points in no particular order. So if we're looking at triangle ABC congruent to DEF, then I can say that side AB is congruent to side DE. And the reason I can say that those two are congruent is because they're in the same location in our congruency statement. AB is the first 2 letters of our congruency statement, and DE is the first 2 letters of our congruency statement. Therefore, those 2 sides are congruent. Then I look at the last 2 letters, BC, and the last 2 letters, EF. And since BC and EF are the last 2 letters, that means that BC is congruent to EF. And then finally, the last side, because the triangle has 3 different sides, the last side would be AC, the first and last letter, congruent to DF, the first and last letter of our congruency statement. I can list the angles that are congruent to each other if triangle ABC is congruent to DEF without a picture. It's all about location in the congruency statement. Notice how A and D are in the same location, first letter of each statement. So that means that angle A is congruent to angle D. B and E are in the same location, so angle B would be congruent to angle E. And C and F are in the same location, third letter of the statement, so angle C would be congruent to angle F. Now let's throw a picture in here. So we're going to mark on the 2 triangles which sides and which angles are congruent given this congruency statement. I'm going to start with the angles first because I think it's the easiest. So A and D are in the same location, so I would mark angle A congruent to angle D. B and E are in the same location, so this time I'm going to use 2 arcs to mark B and E congruent. And C and F are in the same location, so I'm going to mark C congruent to F, and I'm going to use 3 arcs. Now let's look at the sides. AB, first 2 letters, congruent to DE. So AB, I'm going to mark congruent to DE. BC, last 2 letters, EF. So BC, I'm going to use 2 arcs, or 2 hash marks, would be congruent to EF. And then finally, AC, first and last letters, congruent to DF. I'm going to use 3 hash marks. AC is congruent to DF. Alright, list the sides and angles that are congruent to each other given that CAKES is congruent to YUMZ. So list the sides and the angles and then mark the sides and angles congruent in the following. Go ahead and pause the video, give this a shot, and raise your hand when you're finished. Okay, now I'd like for you to go ahead and glue this into your notebooks. This is the example that you should have grabbed at the beginning of class. Now we're going to use our congruency statement. This time polygon BCDE is congruent to polygon RSTU. So we're going to use the congruency statement to find each variable. So we want to find X, we want to find Y, there's a Z in here, and we want to find W. I'm going to do 2 examples with you, and I'm going to have you do the last 2 on your own. So first I'm going to look at the W. There's 4W minus 7. And if you look, you see that side BC is the first two letters of the congruency statement. So it would match with side RS, the first two letters. So I come down here and I look for side RS. So I would mark side BC congruent to RS. So using the fact that those two sides are congruent, I would set 4W minus 7 equal to 2W plus 13. Subtracting 2W from both sides, I would get 2W minus 7 equals 13, and 2W equals 20, so W equals 10. And then I would substitute my W back in. 2 times 10 is 20, plus 13 would be 33. And 4 times W would be 4 times 10, which is 40, minus 7 is 33. So these are in fact congruent. Now I'm going to look at X. Notice that angle B is the angle that represents the expression 2x plus 9. So I look to see which angle is congruent to angle B. Angle B is the first letter in the congruency statement, and angle R is the first letter of the polygon RSTU. So angle B, which is 2x plus 9, would be congruent to angle R. So algebraically, I would set angle B, which is 2x plus 9, equal to angle R, which is 49. And I would get 2x equals 40, so x would be 20. And then I would substitute my x in here. 2 times 20 is 40, plus 9 is 49, and that does in fact equal 49. Alright, now I'd like for you to pause the video, solve for y and z, and see if you get the same thing that I get. Okay, you should have gotten y is 42 and z is equal to 3. Alright, now we're going to do what are called congruent shortcuts. And these are postulates and theorems that prove that two triangles are congruent, not knowing what all the angles and side lengths are. The first one is the side-side-side postulate, the SSS postulate. And the SSS postulate, or side-side-side postulate, says that if three sides of a triangle are congruent to three sides of another triangle, then the two triangles are congruent. So let's just say I was given two triangles and you had one side marked congruent to the other, another side marked congruent to the other, and the third side marked congruent to the other third side. If you have three sets of congruent sides in each triangle, then that tells me that these two triangles are congruent. So let's just say this is ABC and this is DEF. Then I would say that triangle ABC is congruent to triangle DEF. Okay, then we have what's called the SAS postulate, and that is actually the side angle side postulate. The side angle side postulate says that if you have two sides and an included angle marked congruent in one triangle to another, then the two triangles are congruent. So let's say we have this side marked congruent to this one, this side marked congruent to this one, and then the included angle. The included angle would be the one that is in between these two marked sides. So right here. Right here. So this would be the side, the angle in between, and the side. The side, the angle in between, and the side. Then I could say that these two triangles are congruent. Okay, then we have the angle side angle postulate, the ASA postulate, stands for angle side angle. And that says that if you have two angles, let's just make sure we mark them differently. Two angles and then the side in between the two angles. So here's the two angles, directly in between them would be right here. Here's the two angles, directly in between them would be right here. Let's make that a little nicer. So if you have two angles and a side in between them marked, then these two triangles would be congruent. So angle, side, angle, angle, side, angle. Okay, then we have the angle side theorem, the AAS theorem, and that says if you have two triangles, let's do two triangles, make them look congruent. If you have two angles, so 1, 2, and the side that's not in between the two angles, so here's 1, 2 angles, in between would be right here, we want it to not be in between, not be in between. Then this would be the angle, side theorem. The angle, side theorem. It can also be written as side, angle. It doesn't really matter except that you won't see it written like this, like as a multiple choice quiz or anything like that. And then finally we have the HL theorem, and that is only in right triangles. And that says that if you have two right triangles, so one of these has to be marked right in each triangle, and you have the hypotenuse marked congruent to the other hypotenuse, remember the hypotenuse would be across from the right angle, and you have a leg marked, so it wouldn't matter which leg, then these two triangles would be congruent. And this only works for right triangles. Only for right triangles. Very important. So you'd have to have two sides marked, one being a hypotenuse and the other being a leg, for this to be a set of congruent triangles. Okay, that will wrap up congruent triangles, and you'll be working on your practice.